Hi everyone. As promised, I want to give you a discussion on the sample test on this Halloween night, and I hope that you all got your fill of sweets. But now let's get to work. All right, let's turn this camera around. Now let's take a look at the problem. The problem here says that given there's a quadratic function and there's a vertex of -1 and 1 and y-intercept at 0 and 2, and we need to start first sketching the graph, and then we will solve for the algebraic expression. So we'll do part A and part B together, and then let's think about just overall looking at the graph, looking at the problem. So the part C says find a coordinate of 2 points when g of x equal to 2 and f of x intercept. So if you think about it, you can think of, right, this already set up is saying that this is a quadratic function. So quadratic function basically is a parabola, right? And imagine there's a parabola, and then part C says there's a line, right? G of x is equal to 2 is a horizontal line, and it will cross, right, intercept. So it's going to probably, at best pass 2 points. So we'll have 2 answers, right? And then part D says there's another function g of x equal to 3. So it's possible that it's gonna give you another value, and you had to come up with 2 points, two intersecting points. Lastly, E, when you have I of x equal to -2. Now, it's possible you can have 2 points, 2 answers. You can have 1 answer if it's intersecting at the vertex, or you don't intersect at all, and your answer is going to come up with a complex answer, right? So start out. Let's go ahead and start solving this problem. So I'm going to point the camera to the paper right now. Okay, so the problem gives us a vertex at -1 and 1, intercept is 0 and 2. Let's take a real quickly to sketch out the graph. So if you look at the graph right here, I start out with a vertex at -1 and 1 right here. And I sketch out the 0 and 2, 0 and 1, 2, right? So you draw one side of the graph here is a parabola. It's a vertex, that means on the other side it's going to have a symmetrical shape going this way, which means that this point right here, the intercept that's given to us, the second point, is going to give us a corresponding third point on the other side. And that one is going to have the same it's predictable in terms of where the position is. It's going to be one step over and at the same horizontal height, right? So same height. So it's going to be at -1 and and -2 and 2, right? So this is the point, right? So this is the graph, and once you get this graph down, you have all the coordinates and all that. This is perfect, and you had to make sure you had the visual. So as you can see, I had these values: -1, 1 for the first point, 0, 2 for the second point, and then correspondingly -2 and 2. This is a comma right here. -2 and 2 right here. Now this allows us to be able to take advantage of that and solve the problem right here. So what I will do is I will simply just use a simple XY table to keep track of my values, right? X and Y. So first one, I always use the one with the X equal to 0. That's the easiest. Now, if you don't have that, if somehow your 3 points doesn't have any X equal to 0 values, that's okay. You just go with it. The fact that I have a 0 for X, I put that first because I want to use that first. So I have 0, 2, first point. That's the y-intercept. I got a vertex -1 and 1, and then the third point that I found was -2 and 2, right? So now I go back to the general form of the quadratic, right? So y is equal to f of x equal to ax squared plus bx plus c. That's the general form. Any quadratic equation in parabola will have this expression, this form. But the key point is what makes this a unique any unique particular parabola is because of the specific value of a, b, and c. That means we need to figure out what a, b, and c's are. So let's start with using 0 and 2. Use the first point. Okay, so we'll use the first point. Now the first point, 0 and 2, I put 2 into the y value. So as you can see, I lined them up pretty nicely so I can keep track of them. 2 is y is 2 right here, equal to, and then a times x is equal to 0, x squared, plus b times x, which is b times 0, is equal to c. Simplify this, right? Any 0 value, 0 times a and b and all that will become 0 terms. So you end up with 2 is equal to c. Immediately I found the c value. Okay, so this is, we made use of the first point. Now let's make use of the second point, which is negative 1 and 1. Okay, here's negative 1 and 1. Use the same equation again. So y is equal to 1, equal sign, I line it up as an equal sign here. And then a times x squared is negative 1, so a times negative 1 squared, plus b, right, times x in this case is negative 1, plus c. Hey, c, we just found out c is equal to 2, so I went ahead and make a use of it. Then simplify this. 1 is equal to a, right? Negative 1 squared is 1, so 1 times a is a. This is b times negative 1, so it's minus b plus 2. Now, in this case, I have a constant here, so I bring the constant to the other side, which is subtracting 2 on both sides. I end up with negative 1 is equal to a minus b. I said that as the first equation. Now, because I still need to find a and b, right? I have exhausted the usage of this coordinate to get me a and b. So I'm going to use the third coordinate, negative 2 and 2. So I'm going to use negative 2 and 2. Again, going back to the general equation. So I have 2 is equal to a by a times x squared, negative 2 squared, plus b times x. X in this case is negative 2. So it's negative 2 right here. B times negative 2 plus c. Oh, c is 2. Again, we found that earlier. So right here. Simplify this. I get 2 is equal to, right, negative 2 squared is 4. So it becomes 4a. B times negative 2 becomes minus 2b. And then plus 2. So there's a constant right here. So I subtract 2 on both sides. I end up with 0 equal to 4a minus 2b. Now, I could simply just use this, or I can say I want to simplify this a little bit more because I noticed that I can compare this with the previous equation that I found, which is a minus b. Notice that this has coefficient on a and b, but I can factor out the 2 on both terms, right? So divide every single term, divide 0, divide 4a, divide negative 2b by 2. I end up with 0 is equal to 2a minus b. Call that equal to the second equation. This is all come out as a consequence of using the third point, negative 2 and 2. Now notice that I have first equation I found using negative 1 and 1. I found the second equation using negative 2 and 2. Bring this first equation down and line it up here, right? I line it up here. Negative 1 equal to a minus b. Now notice I line them up. I can subtract. So 0 minus negative 1, right? 0 minus negative 1 gives you positive 1. 2a minus a is equal to a. Negative b minus negative b is equal to 0. So, a is equal to 1. That's great. I found out what a is. And then I bring it back to the previous equation I have. I get negative 1 is equal to a minus b. So in this case, negative 1 is equal to a, but a is a minus b, but a is equal to 1. So it's 1 minus b. So this is b equal to 1 plus 1. So b is equal to 2. So now I got all three values. Notice, right? Zoom out a little bit. Notice I have C is equal to 2, A is equal to 1, and B is equal to 2. Put it back into the general equation, right? Put it back into the general equation. Ax squared plus bx plus c. There you go. You got f of x is equal to x squared plus 2x plus 2. Now, going to the next problem. The next problem says, right, part C says, okay, now we need to find the coordinate of 2 points. The coordinates of the 2 points when f of x, which is what we just found, right? We just found out f of x is equal to x squared plus 2x plus 2 will intersect with g of x equal to 2. Basically, these two things gonna intersect. Now we noticed that the graph earlier looked like this, right? Right? You got negative 1, 1 right here, and you got 0, 2 right here, and then you got negative 2, 2 right here. And then right now we had g of x is equal to 2. So g of x equal to 2 means that you have a horizontal line going across like this. This is f of x. This is g of x. Now, technically, you could just come out with a 2 answer because this graph is pretty obvious, right? This shows that this is 0 and 2 right here. This is negative 2 and 2. Seem very obvious that these 2 points are exactly the intercept between g of x and h of x. Now, obviously, I'm looking for you to show this algebraically, right? So then what we do is algebraically we set f of x and g of x equal to each other. Now when you do so, right, let me just adjust the camera a little bit so you can see this a little bit better. When we do so, then I line them up, right? F of x is equal to x squared plus 2x plus 2. G of x is equal to 2. So basically, I'm solving this quadratic equation. So algebraically, this is basically is a way to say, or algebraically using number and symbols to describe what's happening in this picture, in this graph, right? So this is the graphical understanding. This is the algebraic understanding of the same concept. Now, when we solve this, very simple. We notice that there's a 2 here. There's a 2 here. We can bring this 2 on the other side. Becomes 2 minus 2 becomes 0. So you end up with x squared plus 2x equal to 0. If you have x squared plus 2x equal to 0, this is a very simple practice, exercise of factoring out the x. You get x times parentheses x plus 2 equals 0. You have two things multiplying to each other equal to 0. That means you can set x equal to 0 and x plus 2 equal to 0. By doing so, first x value is 0, second x value is negative 2. Now, it corresponds to this one and this one, right? These two x value, that gives you the corresponding coordinates. So that means now this problem, this part of the problem asks you to find the coordinates. Coordinates means you have to have x value and y value. You can look at this graph, or you can plug it back in. Obviously, you'll get these two points. So you have 0, 2 for the answer and negative 2, 2 for the answer. You look at the graph, you verify, confirm that it is true. Perfect. Now, when we go to the next one, next part B says we still have the f of x, right? No change. But this time we have a h of x equal to 3. H of x equal to 3. Now, again, if you sketch this graph out again, I'm sketching it out again. You don't have to on the test. but I'm just simply, just for the sake of explaining this problem to you, I'm sketching it out again. So you got vertex right here, negative 1, 1. You got intercept here at 0, negative 2, 0, 2. And then there's another point, corresponding point, negative 2. 2 is like this, right? This is f of x. But right now you have a h of x equal to 3, so 3 is right here. 3 is right here. So you got you got a line right here, g of x equal to 3. So that means you're looking at this intersecting point. You're looking at that intersecting point. But luckily you only need to find the x value of the coordinates. If you read the problem carefully, the problem says x values of the coordinate. So all you need to do is find this x value and this x value. So x1, x2. Okay, so that means you need to set those two equations algebraically, set them equal to each other. When you set them equal to each other, you say x squared plus 2x plus 2 is equal to 3. Now, this one, then you can go ahead and move the 3 onto the other side and make that x squared plus 2x minus 1 equal to 0. Now, obviously, this is a quadratic equation, not an easy thing to factor perfectly. So we're going to use quadratic formula. And we use quadratic formula. Looking at this quadratic equation, we identify A being 1, B being 2, and C being negative 1. If that's the case, then we're going to go ahead and use the quadratic formula. Now, quadratic formula right here, right? Negative b plus minus square root of b squared minus 4ac divided by 2a. You can get around with this. You just got to memorize it, okay? And then be able to use it. Now, simply apply these values into a, b, and c in the quadratic formula. You end up with this, right? You end up with negative 2 plus minus square root of 2 squared minus 4 times 1 times negative 1 divided by 2 times 1. This is all just simple plug-in. Okay, you should be able to do that. After you finish doing that, you go ahead and simplify this. Then you end up with negative 2 plus minus square root of 4 plus 4 divided by 2. Now, square root of 4 plus 4 is equal to square root of 8. Now, square root of 8, if you factor it out, it's 2 times 2 times 2. Right? So that means square root of 8 can be written as 2 square root of 2. So I'm going to go ahead and do that. So I end up with negative 2 plus minus 2 square root of 2 over 2. Now I have two terms on the top, one term on the bottom. When you simplify, you have to deal with this portion, and then you can so then this becomes negative 1, right? This becomes negative 1 plus minus square root of 2. Negative 1 plus minus square root of 2. Okay, perfect. Now let's go to part E, the last portion. The last portion says this. The last portion says that you have f of x, same thing, but intersecting with I of x equal to negative 2. I of x equal to negative 2. If you remember the graph, let me just sketch a graph again real quick. Negative 1 and 1, 0 and 2, negative 2 and 2. You got this. This is your f of x. But you have I of x equal to negative 2. Turns out to be right here. Negative 2 is right here. So you have this graph right here, I of x. Notice they're never going to touch. That means you're never going to have a real value for your answers. But we know that the difference between algebra 1 and algebra 2 is because is that algebra 1 asks for you to look for a real answer. Algebra 2 here going to ask you to provide a complex answer, which means that it involves imaginary values. So go ahead, let's go ahead and set them equal to each other. So we got x squared, right? We got x squared plus 3x, no, I'm sorry, plus 2x plus 2 is equal to negative 2. And by doing so, you bring negative 2 onto this side, you end up with x squared plus 2x plus 4 equals 0. Now this is still a quadratic equation, which means you just go ahead and use quadratic formula. And then identifying a equal to 1, b equal to 2, c equal to 4. Once again, quadratic formula is right here. Simply applying these value of a, b, and c into the quadratic formula. And by doing so, your first step, one at a time, will look like this. Negative 2 plus minus square root of 2 squared minus 4 times 1 times 4 divided by 2 times 1. Then you end up with negative 2 plus minus square root of 4 minus 16 divided by 2. Which means you end up with, okay? Which means you end up with negative 2 plus minus square root of negative 12 over 2. Now, 12, if you factor this out, 12 is basically 2 squared times 3. Okay? So that means you can rewrite this expression as negative 2 plus minus square root of negative 2 squared times 3 over 2. Now the 2 squared inside the radical can come out and just becomes 2. So you end up with negative 2 plus minus 2 square root of negative 3 over 2. Now this is the top portion, this portion right here. This portion right here is negative 2 plus minus 2 I square root of 3 over 2. Again, you can simplify all these terms. You end up with negative 1 plus minus I square root of 3. So now you have two x values over here, but it's in the complex form. Complex numbers. But that's essentially, this is your answer. And this corresponds to your prediction of what this problem will look like, which in this case is that these two functions do not touch, at least not in a real number space. That makes sense? All right, that's it for today. Part B, number 2 of the sample problem is for you to derive the quadratic formula. See one of my previous videos, and you will be able to see the explanation. See you next time.